Hello. Yeah. All right. So we'll just get started with the first class. Um, so right, let me share my screen and then we'll get started. So the today is going to be the first class. So as I really speak about and share some of the materials. Whatever the materials that I'm going through and whatever is needed for a hands-on labs and everything, I'm going to share it with you. So sorry. So first, today's class is more about understanding the basics of data warehousing. And once we are clear with the fundamental concepts and some of the definitions, which are basically needed for a, which are basically needed for the, which are basically needed for your ETL development process. So we'll understand that, and then we'll just move on. Right. So, as we understand from after the demo class, basically the data warehouse is something that it's the collection of data or integration of data from the different transactional systems, and which is actually being used for analysis purpose. That's called as a data warehouse. So in layman terms, basically data warehouse is nothing but the database. Any database can act as a data warehouse basically. So as I said, so any database you choose, whether it is Oracle or a SQL Server, Teradata, any database I can choose that can act as a data warehouse. So it's a database where we are storing the data for analysis purpose, where we are storing the data for analysis purpose. So that's called as your basically the data warehouse. So as I said, again I repeat, basically this is very important. People understand that data warehouse and the database are completely two different things, but not the same. But not true. The data warehouse, database itself can act as a data warehouse. So most of the time you come across the projects which are implemented Teradata as their data warehouse, maybe 30 to 35%, and then Oracle followed by the SQL Server. And nowadays, the MPP databases like Netezza, and now since the cloud is taking up fast, and AWS and all, so most of the people are even started using Amazon Redshift, and likewise any database. If you see even MySQL, I can just take that as a data warehouse and then start building my own data warehouse for a e-commerce platform or anything. So that's the basically the fundamental thing. Okay, so to understand the definition of it, see, data warehouse is not a technology as such. It is basically a concept or a theory which is proposed by a scientist called as a Bill Lemon. Bill Lemon is a guy first who proposed a data warehousing system, and then said that, okay, if you guys are building the data warehouse and this can be useful for analysis purpose, Bill Lemon, and his thoughts have been carried out, and then a lot of the innovation happened in the data warehousing methodologies and the practices, which have been carried out by another scientist called as a Rolf Kimball. Rolf Kimball, you even have a Rolf Kimball University separately, which talks about the data warehousing best practices and everything, right? So this is, these guys have proposed, and this is not a technology, this is just a process. Then what is the technology involved in data warehousing projects? So that is nothing but your ETL. ETL is a technology. ETL tools, whatever we talk about, that is a technology which is involved. And database is a technology. Whatever the database that we are choosing, or BI tools are your technology, right? Business intelligence tools with respect to that. So these are your basically the technology which is involved, or a database is also the technology, right? So let's understand what Bill Lemon had to define about the data warehouse. So he defines the data warehouse as it is a, these are all the characteristics of the data warehouse, what Bill Lemon has actually defined. It is called as a subject oriented system, right? Subject oriented. And he calls this also as an integrated system, right? Integrated. And we call this as a time variant and non-volatile. Non-volatile is basically the subject oriented, integrated, time variant, and non-volatile system, which is used for a decision making. That's called as a data warehouse. So we'll understand. I mean, let me recall the example that we talked about yesterday, right, on the demo class. So I would like to tell you there will be a different transactional systems in an enterprise. I'll just redraw the similar kind of a diagram. So where you have Salesforce, which is an application which is used for your marketing and the sales purpose, and you have the other applications like a FlexiCube, or let's say for a credit card management application, let's say for credit cards, which we have, right? And similarly, there is maybe another application which we call it as, let's say the FlexiCube is a core banking application. Likewise, there may be a many applications in a single enterprise about all your transactional systems. So these are all your transactional system where every day the new data that will be added, whenever a new customer is being added to your CRM system, that customer information will be recorded here. Whenever a new transaction happens on a credit card issued by you, issued by the bank to the customer, that will get recorded over here. And any deposits and withdrawals directly at the bank, that will get recorded over here. Likewise, there may be a different other, for a taxation purpose, they might use another application. Likewise, there may be a multiple transactional systems will be present in a single enterprise. So we are going to read the data from all these things and then create a the centralized database. It is like a common collective database which we are going to integrate from all these applications into a single database that is called as your data warehouse. So basically, this is on a note with respect to your data warehouse, right? So let's talk about, let's say, data warehouse, which we call, and this can be, you can choose anything. At the end of the day, whatever what we store in the data warehouse is a data in the form of a tables. So that could be anything. So whenever you're building a data warehouse, basically what Bill Iman says is that it is more about the subject oriented system, right? Subject oriented. So subject oriented means, see, basically whenever we are building a data warehouse, we categorize the data according to the each subject area or according to the each department in an organization. So subject oriented, which is more about, when you say subject oriented system, it is basically summarized. Data is organized and summarized based on the topic or based on the each department. What I'm trying to say here is, let's say whatever the data that is related to the sales department, we store in a separate set of tables. Whatever the data that is related to the marketing department, we store in a separate tables. Whatever the data that is related to the finance department, we store in a separate set of tables. Since because you are categorizing the data according to the each topic or each department, that's why we call the data warehouse as an integrated system. Subject oriented system, which it is there, right? So the next one is on the integrated. So what do you mean by integration? You're actually combining the data from multiple systems, the multiple sources, right? So there are multiple sources from which you are integrating the data, and all these sources may not be similar in nature. Maybe here the data is actually stored in some Salesforce database. Here, let's say your data is captured in Oracle database. In FlexiCube, let's say the data is actually captured in the SQL Server database. Likewise, so if you see these applications, these are not homogeneous in nature, right? It is heterogeneous in nature. So you're actually integrating the data from multiple sources and diverse sources. So what do you mean by diverse sources? It's nothing but the heterogeneous sources which are not same, basically. That is your diverse sources what we have. And also, it is also possible that in an enterprise, all the time the data might not be present in an application or maybe in a database. So in few cases, you may have a data which is present in XML, or you may have a data which is present in a flat file. So I want to integrate that data as well. So you can even integrate the data from a diverse formats. Means the data which is available in the table level, the data which is available in the file or an XML, all these things is basically integrated and built. That's why it is also called as a integrated system when you call about integrated system. So that's why we call a subject oriented and the integrated system. And the next one is more on the time variant. Okay, this is very important. See, when you talk about the transactional system doesn't store the historical data. Okay, let me give an example. Let's say you have an ATM withdrawal application, right? That ATM withdrawal application is actually, if you go and see, you'll not be able to see the historical transaction what is performed, right? Maybe you may be able to see last 6 transactions or 8 transactions what you have performed in an ATM. But if you want to see the what was my transactions in the last year, or I mean last quarter, so basically you'll not be able to see the historical data in the transactional systems. So no history will be present in the transactional system. But when we are building a data warehouse, since the integration of data from all these transactional system is a continuous process, over a time period, your data warehouse will store the historical data. Means every day you're integrating the new data, collecting it, adding it to the data warehouse. So likewise, your data warehouse becomes historical. You'll start storing the data for over a time period, and whenever you want to access the data, which was historical data, it is easier for us. So what I'm trying to say here is data warehouse is historical in nature. If you want to access the data for a last 12 months, yes, we can access it. Or let's say you want to find out last quarter data, right? Last quarter data, so that you can access it. Or let's say last month data or previous to previous year data. Likewise, the historical data is present in a time variant system what we have, right? So time variant, why we call? Because it stores the historical data for 12 months, 6 months. I mean, most of the time we even store the data up to 5 years. It depends upon a business to business and implementation to implementation. Since the historical data is present, so then it is also called as a time variant system, right? And the other one is about the non-volatile. Volatile means which changes very frequently. The data in the transactional system is volatile in nature, but when you talk about the data warehouse data is non-volatile in nature. Once we load the data, we are not going to do a frequent updates on the data warehouse. Data doesn't changes very frequently on the data warehouse, or once we are going to enter, we're not going to remove it because we need a data for a historical analysis. So we don't remove that. That's why a data warehouse is non-volatile in nature, because the data is not frequently changed, just like your transactional system. Once it is loaded, it is going to be used for a long term. So that's why we call this as a non-volatile system when you see that. So these are the different characteristics of your data warehouse. So he defined Bill Limon has defined the data warehouse as a subject-oriented, integrated, time variant, and non-volatile system, which is used for a decision making. So similarly, the Rolf Kimball has also given one definition. So he defines the data warehouse as it is a historical transactional snapshot. You're actually storing the history of all the transactions what are happened in the OLTP. That's why he termed it as historical transactional snapshot. Okay, historical transactional snapshot. So this is the definition given by the Rolf Kimball. These guys are the basically you can call it as a scientist of the data warehouse, or Bill Limon is referred as a father of data warehouse because he proposed the data warehousing system. That's why he defines the data warehouse as he referred as a father of data warehouse. So this is a simple definition which is given basically by the data warehousing. I mean, for a typical data warehousing, right? Any questions so far?
Karthik, one question here. So to take the same example, like when we log into a bank account, we see the current balance, and also at the same time we have an option to see like mini statement or the detailed statement, right? So if I correlate with your example, is it like the available current balance is taken from the OLTP system or the database which is maintaining the latest status, and the mini statements and detailed statements or the list of transactions I see, is it coming from the data warehouse?
It's not comes from a data warehouse, but it comes from another thing called as an ODS. We will talk about ODS, that is operational data store. For a general operational reporting, they store basically for 3 years of data or 2 years of data, depending upon the transactions. Without transforming the data, we store it in another separate operational database, which is called as an ODS. Generally, we pull it from ODS, but once it is loaded into the data warehouse, it is more suitable for analytical purpose, but it may not be the relevant thing to it may not be so relevant to do the operational reporting, but we'll talk about this. Yes. So your question is absolutely valid. It's basically the detailed statements and the historical statements, or whenever you go to the banks and everything, those are not generated from a transactional system, but we build another application for an operational reporting that is called as an ODS, operational data store. From there we pull it, right?
Okay, and the available balance or whatever comes from the OLTP or
the transactional system.
Okay.
Right. All right. So basically, the next thing is more on a understanding of differences between a transactional system and differences between a transactional system and the data warehouse. So as we understand, and even from the demo class, see, the OLTP is basically it's where frequently the data is being added, updated, and deleted, and there will be many users who will be accessing the OLTP application. So as I given you multiple applications yesterday, so if you talk about Amazon.com, which may be accessed by the millions of customers, and maybe another example is about eBay.com, or if you talk about an internet banking system, which we call if you have million customers, there may be a chance that million customers could access your internet banking or your Android application or an iOS application which you use. And then similarly, let's say the order management application, which may be used by the complete set of users who actually creates your orders and invoices. And then the CRM applications like a Salesforce.com could be accessed by the more users concurrently at one point of time, even though it's a cloud-based application. So likewise, all these transactional systems, whichever is there, these are basically where you have a frequent updates, inserts, and the deletes which will be happening on the transactional system. So most of the time we don't really store the historical data, as I said, but it depends upon an application to an application. Most of the times your design may consider, OLTP system design may consider even up to store the last 90 days of a data, depending upon a business purpose to the business purpose. It's not mandatory that every transactional application will store the 90 days of data, something like that. So it is not stored in that way. It is basically the little historical data, not heavy historical data for years and years together we store, but similarly, the last 30 days of data, 60 days of data, or 90 days of, it's just an example that I'm taking here. So when we talk about these OLTP, I want also you to understand the data which is organized in the form of tables in the OLTP, it is highly normalized in nature. So the data what is being organized, it is called as a normalized data. Okay, so I want the term normalization is very important here. So what is normalization? See, we all know that in a database, the data is actually captured in the form of tables, right? In the form of tables, the data is really captured. But who is going to organize that data? I mean, you have to properly organize the data for a maintenance purpose and everything. So the organization of data in the form of tables, I mean, organizing the data or a distribution of data in tables, and the defining the relationships between the tables, right? Defining the relationship, which is nothing but primary key foreign key relationship, all these things which will be done through the data modeling process. But when you talk about a normalization is nothing but the organization of data in the form of a different tables. That is called as a normalization. So normalization follows certain rules. I'm not going in detail about it, but I just want to give you an example about normalization follows certain rules. That is called as a first normal form. Means you follow certain rule and then define the data structure or organize the data. Second normal form, third normal form, and you have even a 3.5 NF, basically the 3.5 NF, and then BCNF. It is also called as a Boyce Scott normal form. I mean, you can explore it, but I'm not going into details on it. Fourth normal form, likewise, there are different rules that we apply in organizing the data within your database. So we don't start storing the data in our own interested format, but there are certain RDBMS concepts and the best practices which have been defined by the scientist called as a CORD, EF CORD. EF CORD is a scientist who has actually defined the relational model and everything. So we follow certain rules and then define a distribution of data in the tables. So why I'm talking about this normalization is, these OLTP applications are highly normalized up to third normal form, because it is, if you more normalize the data, it is easier for inserts, updates, and deletes, whatever it is there. And one more important thing that we need to understand here is, the more you normalize the data, more number of tables will be present in the database, more number of tables. So if I'm normalizing up to second normal form, the number of tables in the second normal form, the number of tables in the third normal form will be always higher. What I'm trying to say is, number of tables in the second normal form is less than number of tables in the third normal form always. So basically, the more you normalize the data, more number of tables will be present, but the anomalies and the duplicates will be eliminated. You don't more you normalize the data, duplicate data may not be present across your tables. It is just that always we divide the data into different tables and manage it. So more number of tables will be present within the right. So more number of tables will be present in the database when you normalize high. So now I would like to ask you a question. So is it good for a reporting purpose when you have a more number of tables? See, reporting means basically I would like to analyze the data. If I have more tables, obviously the analyzing the data becomes complex. So why analyzing the data becomes complex when you have more tables? If you have more tables, obviously you need to write a more number of joins required, right? More joins required to write the query. I mean, see, reading the data from 2 tables is always easy than reading the data from 10 tables. That's what I'm trying to comment. Okay, so when you have more number of tables, you need to use more joins, and the query becomes complex, right? Query becomes complex, right? And if you're writing a complex query, obviously the data retrieval process takes a long amount of time. I mean, takes a long time to retrieve the data and everything. So what I'm trying to tell you here is, transactional systems are not suitable for an analysis purpose, because you'll have a more number of tables present in the transactional system. You need to write a complex queries, and there is no historical data. Always you cannot compare the historical data versus present data to understand the growth, everything. So it has its own limitations for analysis purpose. But transactional systems are suitable for a day-to-day operations, but it is not used for a analysis purpose, because there is no historical data. more number of tables will be present, and you need to write a complex queries to retrieve the data. That's why we don't analyze the data on top of an OLTP. That's why we are building a separate application. So what is the use of data warehouse? Data warehouse is used only for analysis purpose, just for analyzing the data, just to understand how you're doing in your business. That's why we are building a data warehouse. Otherwise, there is no need of a data warehouse. If you don't do analysis, there is no need of a data warehouse, right? But how analysis can help you, that's what we're going to understand in the coming slides. Okay, so that is on the transactional system. But when you talk about OLAP, right? So now we understand, okay, OLTP is more normalized in nature. Then what about OLAP? How are we going to build the OLAP? When I say OLAP or a data warehouse, or some cases, the data mart, you could call it as the same, but we'll understand what is data mart. Okay, OLAP or a data warehouse, it is basically for a reporting purpose. We always store the data in the denormalized form. Denormalize, opposite to normalization is, we don't normalize heavily. Most of the time your data warehouse is actually denormalized up to, the second normal form. We don't go to third normal form as well. It just will stop it at the second normal form. So when you do the second normal form, obviously if you have 100 tables for a CRM for storing the data, let's say 200 tables which are there, but when I translate all these 200 tables, I maybe shrink down this to basically to some 10-15 tables, maybe some 5 fact tables and the 15 dimension tables. Okay, maybe 20 tables which I can break this OLTP model into 20 tables. So obviously the number of tables are less in the data warehouse when you compare to your transactional system. So that's why we denormalize up to second normal form. And when you denormalize less number of tables, and you can write a simple queries to retrieve the data, that is an advantage of a data warehouse for analysis, because we store the data in the denormalized structure, less number of tables will be present, and we can retrieve the data faster than the transactional system. But very important thing is that your transactional systems are not storing the historical data, right? But your OLAPs does store the historical data whenever you, it stores the historical data over a time period, right? So let's understand some of the characteristics. This is just for our understanding purpose, to differentiate how OLAP is, what OLAP is suitable for, and for what OLTP is basically suitable for, right? So as we are speaking, the OLTP is more for a day-to-day operations. We don't do any analysis, and this is to understand the information about your business. How you're doing, whether you're doing good or bad, are you running in a profits or losses, all these things. This is a transactional system and this is an analytical system. And who uses the transactional system? See, if it is an internet banking, a customer of Bank of America will use it, right? And basically, if it is a order management application or invoice application, somebody who is there in a Bank of America system, they use that application. So likewise, even who uses the Salesforce application, the marketing department who is actually targeting the customers, they use that Salesforce application. So right, but OLTP is completely used by the I would say the low level workers, and not the who are there in the top level category. But OLAP, yeah, this is very important. See, now from the beginning we are saying that the data warehouse is actually used for analysis purpose. Who is going to analyze the data? Data will be analyzed by the knowledge workers. When you say knowledge workers, maybe the CEO of the company, COO of the company, or a bank managers, or let's say East Coast bank manager, East Coast managers, or a West Coast manager, or top level hierarchy. So they who understand the business well, they uses the analytical system. That is your knowledge workers. And see, basically the guy who is creating an invoice in your transactional system may not be using an analytical system, right? So this will be used by the branch managers or a sales managers of the country, or high level workers, the high level knowledge workers, they use it. So it is day-to-day operation, and it is more current data, and it is historical data. This is relational in nature, and this is more summarized for a reporting purpose, right? And the simple transactions will be happening, but we write a complex queries to analyze the data. We write a complex queries. So in the OLTPs, it's always we'll read the data, write the data, delete the data. But most of the time in OLAPs, once we load the data, it's just that we are going to read it, but we don't delete it as such. So that is another advantage. Okay, so this is important. Since the data will be continuously being added to the OLTP system, every day the data will be kept on adding it. There is a new customer, you go and record that information, right? So since we don't store the historical data in the transactional system, basically the volume of data in the transactional system will be less. But since every time we store the data, the historical data is captured in the data warehouse. So basically what happens is over a time period, millions and millions of records gets created in the data warehouse. So if you compare the amount of data in the transactional system to the data warehouse, basically in the transactional system it is tens, and OLAP, it is basically the millions of data will be present which we have. And obviously less data, less size. So transactional system size will be in gigabytes, and data warehouse size will be in terabytes, most of the time even more than terabytes, all those, right? So that's how it will be there. So but if you talk about the number of users who are accessing, let me give you an example. So we talked about Amazon.com. Amazon.com, basically, as I said, it might be used by the millions of customers what Amazon has. But Amazon data warehouse, it will be accessed by the basically the top level team in Amazon. They actually use it. So if you see the number of users who are accessing the transactional system to the warehouse, it will be less. Here, thousands, millions also. If you talk about some of the e-commerce applications, but this analytical applications hardly 100 or even less than that, the people who uses that. And priority is the high performance. Whenever we talk about the performance of the transactional system, right, we always say, okay, how much time it has taken for me to perform each transaction. Let's say we go to ATM withdraw the money and all that. So that basically it's about the transaction. But when you talk about analytical application, it's about the query throughput, right? So how much time it is taking for me to generate one single report, how long it is taking for me to flash up the data in a bar graph format. So likewise, we measure the performance of this. See, these two slides are just to help you to understand what is the nature of both the applications, right? Your OLTP application as well as OLAP applications, what we talked about, right? So yeah, see, the first couple of classes it is more about the theoretical concepts, but as we move on, we speak more on the we speak more on the hands-on exercises and everything. So probably you need to bear with me for first two classes to understand these concepts, right? Any questions here quickly? Right. Okay, so if you're good, let me talk about advantages of the data warehouse, right? See, we are saying, I want you to understand this because this is very important to explain someone about your project, okay? Basically, you're building a data warehouse, you're working as an ETL developer, you're loading the data into ODS, or you're loading the data into data warehouse and data mart. When someone asks you, like, what was use of your data warehouse? Why, how it is being used by, let's say, the Bank of America team, or how it is being used by your Amazon team. So you should be able to explain them the advantage of building that application or advantage of building that OLAP application. So yeah, I'll give you an examples. These are some of the questions which can be answered by your data warehouse. So these are the business queries, and these business queries will be answered by your data warehouse. Okay, now let's say, I mean, since we are talking about the Bank of America, so let's take the similar example again. So if the Bank of America, the sales managers, they want to understand what is the credit card sales on the region wise, maybe in the East Coast, what is there, West Coast, all. I mean, they just want to understand based on the region how it is actually happening. So that can be determined by your OLAP application. So you can just run a simple report and understand a state-wise sales distribution. If you want to understand, you can understand, or you want to go even at the city level, and then you want to understand the sales distribution, you can understand. So this is a simple question which can be answered. Okay, now let's say Bank of America has actually rolled out multiple credit cards. I mean, a type of credit cards, what I mean, multiple type of credit cards, but they want to understand which one is a fast moving product and which one is a slow moving product. I mean, in general in India, you talk about the platinum, gold. Likewise, you may be having a different type of credit cards for Bank of America. But when you talk about it, right? So basically, um, which one is slow moving and which one is fast moving, if they want to understand. See, what is, I mean, you might ask the question back to me again, saying that what is the use of identifying it? So I have some 10 type of a credit cards. So the whoever likes whatever the credit card, they take it, and whoever doesn't like, they don't take that credit card. So what is the use of the finding out that information which is moving fast and which is moving slow? See, basically business users will understand all these type of problems or the queries to resolve them, right? They need to resolve it so that they can improve in their business, right? So basically, if out of 10 type of a credit cards what the Bank of America has, people are liking only one product, then what is the point of keeping all those other 9 type of credit cards? Is it really required? It's waste of your time, and it's waste of your marketing efforts. It's waste of it's waste of money, where you're investing in those 9 type of credit cards to sell them, right? So that is the important thing that we need to understand. By understanding all these questions, they take a decisions. That's why your data warehouse is called as a decision making system. It's called as a decision making system. So basically, again, I'll give you another example. Let's say I have a different sales agents where I'm actually selling my credit cards through, right? I have some 100 or let's say 1,000 sales agents who sell my credit cards. But at the end of the day, I really have to understand who is really helping me to sell these credit cards, right? So if some of them are not doing better, then there is no point in really continuing them. I'll just really push them out of the system, and then basically I'll just continue with the people who is actually helping me to do it better, right? So that way you can take a decision. So that's why top level management is only accessing this, because they take a decisions in improving it, in improving it. So suppose, let's say, if some of the sales agents are not doing better and they're not achieving their targets, basically you'll provide them some performance improvement plan, and you help them with a training, and help them to achieve their targets again, right? So that's another um, important thing. So all these analysis, why we are doing it, is for a decision making, because you make decisions by understanding the data or understanding your business. Okay, now who is a defaulter? See, you've taken a credit card and you have used it and you're not paying the bills, and now they would like to understand what is the total defaulted amount, how many number of customers are not paying the bills, or how many number of customers are not reachable, to even follow up for the payments and everything. So if they understand the defaulters, probably they'll take a measures to collect the payments back. So if you don't understand who is a defaulter, then how are you going to improve your business? So that is another example or a business query which helps you to improve it. And the next one is on the who are my profitable customers. I have issued 1 million credit cards, but out of this, the 10,000 people or 10k people are using very rigorously, and they're really making a good profits to me. So basically what we do, if whoever is a profitable customer, we encourage them to use better, and then we provide them the offers and everything, right? So unless you know that who are your profitable customers, you can't really target them, right? So that is another advantage which you get. Or or to just to understand the revenue growth, how it is improved in the last 5 years. And if you're really the marketing your products through the different channels, which channel gives you the more customers, that you need to understand. Or even data warehouse can help you to strategy planning and budgeting. How much I have to invest in sales, how much I have to invest in IT, or how much I have to invest in marketing, and all those things. You can even do the strategic planning and budgeting. And also, it also helps you to understand, predicts, that is called as a predictive analytics. Basically, you can even predict based on the history of transactions. You can even understand at what point of time you will run into a liquidity risk. At one point of time, okay, there is a currency problem that I may face. Or what point of problem, like you may have to face a interest rate, high interest rates and everything. So this is called as a predictive analysis. The data warehouse and the historical data can even help you to understand and forecast what is going to happen in the future. In next 6 months, how the market is going to be, or in the next 1 year, how my business is going to be turned out. So that's called as a predictive analytics or a forecasting of the business. And it is not only used for a decision making, you can even forecast it, what is going to happen, based on the history of transactions and everything, whatever it is there. So these are the typical questions which can be answered by your data warehouse. Generally, all these questions answered to the business users in the form of a beautiful reports like a bar graphs, pie charts, and everything. We don't generally represent all these reporting in a basically, we don't represent this in fact in the tabular format and all. Whichever is easier for a business users to understand, only those basically those things we show it, and it is easier for a business user to analyze the data. See, if you are actually showing a forecast or a revenue growth, let's say 2010, what is the data? 2018 what, or 17, what is the data? 2003, what is the revenue? Whether it is growing or coming down, or what is the share of credit cards in a eastern region states, east coast states. So likewise, you can basically understand bar graphs, line graphs. So we represent the data in the form of a graphical representation, not based on the tabular format or something. So whichever is easier for a business users to understand, in that format we represent the data with respect to that. So we already understand why we don't use transactional systems, and why we are basically going for OLAP systems. And because you get an advantage of flexibility in accessing the data, and quality data is actually present because you transform it, and bad data is removed before loading the data into the data warehouse. And it is more like a information based to understand how information based to understand about your business and everything. So that's those are the benefits about your OLAP. And when you want to right, so I just want to cover this slide, and probably I'll stop it for today, and tomorrow we'll talk about the architecture of the data warehouse, and then we'll wind up different architectures, data lake architecture and everything. See, whenever you want to build a data warehouse, there are certain steps that you need to follow. It is basically, first you need to understand what is a return of investment. I'm building this basically, I'm building I'm spending $0.5 million to build the data warehouse. If I'm spending $0.5 million, will it really allow me to improve my revenues from 5 million to 10 million? If that is the case, then only I'll go and invest in the data warehouse, right? So first you need to understand return of investment. Basically, what are your key business drivers, and what are your problems in understanding the data? Or who is going to sponsor it? What is the risk that is associated in building the data warehouse? So all those things you first need to understand. This is I'm talking about, it is in the planning phase. When you are in the planning phase, you need to understand all these things, and you need to also know about the requirements for each department. What marketing department wants to know, or what financial department wants to know, or what your sales department would like to know. So you need to first understand their functional requirements according to the each subject area, and then you need to define the architecture. We'll understand what are the different architectures which are available in building the data warehouse for a longer term. And then you need to find out what technology you're going to use, data warehousing technology. That is nothing but which ETL tool, which reporting tool. And then we conduct a small POC. And once the POC is basically conducted, then we define the target database schema. So what do you mean by defining a target database schema? It is nothing but defining and organizing the tables within the data warehouse. Ultimately, in the data warehouse also, we store the data in the form of tables, right? So you must first define the target database schema. Then you define the ETL mappings and all those things, and then load the data into a data warehouse. And the maintenance and administration of the data warehouse is like a continuous activity which you need to take care over a longer period. So I mean, this is basically the steps involved in building the data warehouse. Basically, identifying the transactional systems, identifying your business needs, return of investment, and defining a target database schema, defining the ETL jobs and scheduling them. Yeah, anyway, we'll understand again a complete detailed project life cycle. And once you load the data into a data warehouse, it is just that we analyze and maintain the data for a longer time, right? So that's pretty much about how we define it. So we'll understand all these terminology probably tomorrow. What is ODS and what are the different components within the data warehouse, and what ETL, what is ODS, what is data warehouse, and all those things. Tomorrow we'll talk about the different architectures and how it is there, and then we'll try to complete the module 1, which is there, right? So I want to keep it simple, short for today, because it is more theoretical in nature. I don't want you to feel bored in the late in the evening. So that's fine. Probably we'll stop it for today. And if you have any questions, concerns, and all, probably we can discuss now. Anyone has any questions? Whatever we discussed.
Hello, Karthik. This is Alokya. Can you describe briefly about the normalization part?
See, these are different rules basically which we follow. I think I have to. Anyhow, we'll understand what is a normalization data and the denormalization data when we go to the dimensional modeling. But if you have to really get into the rules and understand, I'll probably talk about in a simpler way about the normalization rules when we go into the data modeling. This is not the right time, but anyway, we'll understand during the data model. That is the next module that we're going to understand. Okay.
Okay.
Right. All right. So if you guys are good for now, so we'll stop it, and we'll meet tomorrow to start on the architecture of a data warehouse, and we'll also understand the latest architectures which are available. The people who are talking about data lake. We'll understand what is a data lake is all about, and how, in a data lake architecture, what is the role of your big data and what is the role of your ETL. That also we'll understand in the tomorrow's class. Thank you. Good night.
Thank you.
I'm closing the meeting for now. Thank you.